Thank you very much for joining me, and welcome to Hands-On Spring Security 4.1. My name is Rob Winch, and I'm the project lead for Spring Security. And today, we are going to kind of apply security to a single-page application and kind of see some of the things that we were talking about in the previous presentation firsthand, and see some best practices with Spring Security. And then we're also going to, along the way, do some white hat hacking. And who here was at my previous talk? Awesome, good show of hands. Who here was not at my previous talk? Okay, so my previous talk was more about the why we do certain things. And it was more theoretical, and today we're doing hands-on stuff. So there's going to be a little bit of overlap between the two talks, but if you were at my previous talk, you should not be bored because you attended my previous talk. It might be boring, but not because of that. And if you did not attend my previous talk, you should not be lost. So with that in mind, thank you again for coming so early in the morning, and we'll go ahead and get started. So I have a whole bunch of slides, but we're going to start off with a demo. By a whole bunch of slides, I mean this is pretty much it. We have the closing slides, but so we're going to do a lot of live demo, as I mentioned. I was actually just running through some of the stuff and getting it all working, and hopefully it's still working. All right, so of course the projector really hates me today and yesterday. Let me see if there. All right, can you guys all see that? So the problem with this is my links aren't showing up at the top. We might have to improvise a little bit in terms of what we're able to do. I think that's just what's going to have to happen because we don't have time to. So the projector hates me, and I am awesome at UI. Can you tell? And there's supposed to be some links at the top, but we can make it work without those links. But anyways, we have this very simple application, and you can basically create some messages. If the link was there, we could create a message. We might not be creating any messages, but that's not really important. The app is not going to be what we're focusing on. And you can view some messages, and you can also, yeah, that's fine. And you can also delete some messages, so we can go ahead and delete one. So it's a single page application, and I have rock solid JavaScript, not really, but it should show you the basic ideas of how to do a single page application from the security standpoint. And we'll also cover some of the basics with JavaScript, but you'll probably, along with myself, laugh at my JavaScript as we browse through some of it, but we are going to talk about that as well. So this very basic application is missing something very important. And what is that? Well, security. So let's see how we can add Spring Security to our project. So the first step for this would be to open up our build file. I just got to make sure, my screen looks a lot different than that, so I'm trying to make sure you guys can still see stuff. So if you see me looking back and forth, I'm just trying to make sure you guys see what's going on. It's optimized for this, and my screen is fun to look at. Let's just say that. So you can see here that I have Spring Boot Starter Security, and it doesn't even scroll. Wow. Oh, there we go. Okay. It's not just my UI that's not liking the projector, it's also Eclipse. All right, so Spring Boot Starter Security is already added to the project. So why don't I have security enabled on the application? Well, there's plenty of things that can go wrong with a demo, and we've already seen my UI as one of those things. But I don't want to update my class path during a live demo, so instead, I'm excluding the auto configuration for Spring Security. If you were actually building this app, you would not delete that. But deleting that is the equivalent of adding Spring Boot Starter Security. So you would not be doing this. You would be adding it to your class path. And at this point, we get a refresh and a basic auth prompt. Now you'll notice I didn't actually have to restart my server or anything. Who here has been using Spring Boot at all? Who here likes Spring Boot? Who here doesn't like Spring Boot? Get out of here. I saw those hands. Get out of here. No, yeah, Spring Boot's awesome. So it has some new features. Anyone heard of the DevTools or been using the DevTools? Awesome, yeah. So basically I have the DevTools on my class path, and what that's doing is it's automatically restarting my server, and it also integrates with the live reload plugin. So that's why I didn't even have to refresh my browser. Just basically picks up that things have changed and it refreshes the UI for me. So it's a really nice feature. Highly recommend Spring Boot. And that guy still isn't leaving. Come on. So what is the username and password that we have to enter? Well, the default username and password is a user by the username of user and a password that is outputted to the console. And the reason for that is we don't want to have a default password that people forget to change, because that never happens. So we type in a user, and then we type in a password, and then we're authenticated. And that was rather easy for me to get up and running. But there's quite a few things missing from this application yet. One of them is I don't want to type user and a GUID every time I need to log in. So how can I fix that? Well, we can open up our resources. And in Spring Boot, this is how you customize things typically. And you can type in a username, and you can type in a password. And at this point, I should be able to go back to my application as soon as it's done reloading, and it's going to prompt me for a username and password. And if I type something invalid, it's going to prompt me again. If I type in rob@example.com, it's actually going to log me in. Now, if my UI was a little better or the projector worked, or I don't know who to blame, but we'll blame myself because I am pretty bad at UI, you'd actually see a username in the upper right-hand corner, and that's being resolved via a endpoint that looks like, if I remember correctly, might need that, yeah. So this is where that endpoint is coming from. And obviously you can't view it in the HTML because we'll say my UI is terrible. But you can see that it's not the user that we logged in as. And the reason for that is because I built up the application before we had security, so how do we know who the user is? So one of the common things that we hear in a single page application is, how do I know what my current user is? Well, that's actually rather easy. So let's go ahead and open up a Spring MVC controller. And obviously you don't need to use Spring MVC for this, but it is the best tool for the job, so I recommend it. And right here you see I have hard-coded luke@example.com. And I'm looking up my current user using my own domain object. So I already have my own domain. A message can be sent to someone, it's from someone. So I have my own user object, and that's typical in most people's situations, right? You don't reuse Spring Security's domain for much of anything, really. So how do I look that up? Well, fortunately, Spring MVC can help me there too. And if my fingers remember which type of laptop I'm on, sometimes on Linux, sometimes Mac. I am all over the place apparently. So basically I'm going to assign the username to the current principal username. And the current username is being resolved from Spring Security. So what's happening? When you log in with Spring Security, it's going to wrap the HTTP servlet request. And the HTTP servlet request has a method on it called getUserPrincipal. So that user principal is how Spring MVC is resolving that argument for us. So that means that the current user's username is in that principal object so long as we're authenticated. So now if I go back to my application and I refresh it, you'll see that I have the correct username. Now, how's my UI resolving that? Well, we can look at that. You can't actually see the result in the UI, but what we can do is we can go to here, and we can look at how I'm getting that user. Get current user, okay. So basically what's happening is whenever I invoke this method, I'm passing optionally a username and a password. So that would be only on login. We haven't got to that point. So right now, it's actually empty. And I make a request, and there's no basic auth header in there at this point in time. We're just making a request to user self. And when I request that, it fails, and it prompts up a dialog for me. So that's kind of how it would work. And we'll go over that in a little more detail momentarily. But the next thing, yeah, this is fun because my logout link is probably not going to be visible either. But so, what's that? Oh, minus. That's a good idea. See, that's why I need smart people in the audience. Thank you very much. Woo! Thank you very much. Thank you. So I act like I'm taking credit. Thank you very much. So yeah, this will make it a lot easier. So now we're able to identify the correct user. But the problem is we're still using basic auth. So how can we customize this to get a better user experience? Because in a browser, we don't want a pop-up dialog. We want to be able to allow the user to log out, and with basic auth, there really isn't a good way to do that in the browser. So to fix that, we're going to have to open up our browser or our IDE, and we're going to add a new class, and we're going to call it security config. Making sure you guys can see stuff again. And so I've added a new class, and the name of it is unimportant, but you do want to extend Web Security Configure Adapter, because that's going to provide us with a lot of good defaults, and at least to get started. And then enable web security is what's saying, hey, look for some configuration within Spring Security. So we have some defaults, and we say, don't look at boot, look for me. And now I should be able to get form-based login, but the problem is that basic auth is stored in the browser, so the browser keeps submitting it, and I support basic auth and form-based login right now. So it's gonna use what the browser is already providing. So the only real way to deal with that is to quit out of Chrome. Well, there's probably a few other ways, but the typical way to deal with that is to quit out of Chrome and then go back to your application, and now you see I get a form-based login. And I can type in rob@example.com and type in my password. So now I'm authenticated, but we still don't have a way to log out. So let's see how we can do that real quick. So what I'm doing here is I already have a logout link prepared, and I'm using knockout.js, and it basically binds to a perform logout link. So now if I go back to here, it didn't auto refresh because I didn't have the live reload plugin enabled, but there's the logout link now. And what's going to happen when I click on this logout link is that I'm going to get an error message. And why is that? Well, let's go back and take a look. I'm getting a forbidden. So I can look at my network, and we can debug it. And you can see it says, well, maybe you could see down there at the bottom. I'm kind of scared to mess with this too much so you can see it, but I don't think it actually pops up. It just comes up in here. So if you can't see it, I'll just read it to you. It says expected cross-site request forgery token is not found. So that should give me a clue as to what's happening. And the issue is, who here knows what cross-site request forgery is? Okay, decent show of hands. We'll cover it in a little more detail for now, but now I'm going to wave my hands and say we need to fix this. And the way to fix that is, first of all, we need to be able to expose the cross-site request forgery token. So I have a security controller here that we've already looked at. And I have a method down here at the bottom. And it provides an endpoint called Crosssite CSRF. And the input to that method is the cross-site request forgery token. And then I can return that cross-site request forgery token back to Spring MVC, and it'll render it as JSON. And how does it figure out what that is? Well, Spring Security provides integration with Spring MVC to automatically resolve that argument. So that is a very handy feature. So we can check that out in our browser. So if I'm making a call, you can see I'm getting a token, and then I'm getting a parameter name and a header name. A lot of times I get asked, well, should I be using this in a single-page application? And the answer is yes. And we'll go over that in a little more detail shortly, but yes, you should use cross-site request forgery protection even on single-page applications. So at this point, how do I get that cross-site request forgery token? Well, right now, I have mocked it because before we didn't have cross-site request forgery enabled because Spring Security wasn't enabled. So I went ahead and prepared this so you didn't have to watch me type. And what are we going to do here? We're going to do a get to the cross-site request forgery endpoint, and then I'm going to populate my model with that token. So that way I don't have to request it on every request. Now, one thing that's interesting is once you authenticate, you want to rotate the cross-site request forgery token because it will change as you log in. And by the way, if you have questions, ask them along the way because that's the best time to ask questions. So if you have a question, yes, sir. Oh, so where's the XML is what you're asking? And how do you configure the filter chain? So the question is how am I configuring Spring Security? Normally I'm used to the XML. So maybe I probably didn't be very clear on that, or maybe you can't see very well. It's probably a little of both. But this actually is replacing the XML. So I'm using Java-based configuration with Spring Security. And this is basically providing a whole bunch of defaults for you that's saying if you're authenticated, or if you make a request to any URL, you must be authenticated. If not, then I'm going to prompt you for authentication. Yeah, so that's the default is just any URL, you must be authenticated. So that's what's in the superclass. We'll override that and provide some customizations. And I think at that point, you'll probably see some familiarity with the XML and the Java config. But this is just providing us defaults to get moving quickly. Does that answer your question? Thank you. Any other questions? Yes, sir. So you're going to have to, it depends on your scenario, but before you authenticate, you probably need to provide the token, so you just have to refresh it after you authenticate. Sorry, I'm not doing a good job of repeating the question. It was, do I get the token before or after I authenticate? And the answer is both, because it'll change as soon as you authenticate. And it's similar to protecting against like a session fixation attack, if you're familiar with that. If not, you can probably Google it. Looks like we're good for questions now. And you might, yes. So the question is, if I'm using a templating language like Timeleaf or JSPs or something like that, do I need to expose an endpoint, or can I just embed it in the JSP or Timeleaf, the template? And the answer is yes, you can. Actually, Timeleaf will automatically include your cross-site request forgery token in forms that are of type post. And same thing if you're using the Spring JSP tag libraries. Same thing if you're using GSP. So there's automatic integration into a lot of those templating technologies that we support. Does that answer your question? Awesome. We're going to take one more, and then we're going to try to get moving, because we do have quite a bit to talk about. If I don't get to your question, feel free to ask at the end, but I do want to make sure that we cover our content. Yes, sir. So is the question, I want to know how to do custom authentication? Yes, we're going to cover that in this talk. And I just need to, I'm checking my phone because apparently my resolution, I know you see something up here, but I don't see a time up here, so I need to see how on time I am. So if I'm checking my phone, I apologize, but I'm just seeing where we're at in the presentation because I have no reference for time at this point. Okay, so we're back to here. So what I need to do is I populate the cross-site request forgery token. And that token, I'm going to close this so I don't cause any problems. That token needs to get populated somehow. So I added an interceptor to my JavaScript. And what I'm doing is I'm getting it from the model. And if it's not in the model, then it's automatically going to get populated via that REST endpoint. And then I'm going to populate it as a header. So at this point, if I go back to my application, if I increase one tab, apparently it does the same thing for both tabs. Now, yeah, I guess I've learned my lesson. So let's see. There we go. So now you can see it again. If I click on it this time, then I will log out successfully. And the reason for that is because it's automatically including that token in the request. And so that's pretty easy for us to get going. But I want to point out a few things. So the first thing is that right now, I can't remember the key binding for Macs for DevTools is, let's see, developer tools. All right, so the first thing that I'll point out is when I click the logout link right now, you can see that I'm getting, you might be able to see, I'm getting a 204. And we'll also verify that in the request headers, we're actually including that cross-site request forgery token down at the bottom. So why am I getting a 204? And the other thing is why is it that that if I request that URL, I'm getting this ugly login page? We just saw the nice, relatively nice login page. The login page that looks as bad as the rest of the application. So why is that? And the answer is that Spring Security actually provides some content negotiation for you. So let's take a look at how that's happening. So if I go into here, you'll see that I'm setting a header for all my requests to be application JSON. If I comment that out, and I keep hitting, oh, there it goes. I actually did get the right one, and I surprised myself. So if I click the logout link this time, and I go back, now I'm getting a 302. So it's doing a redirect. So that's what the browser was seeing when I requested the root page. It does a redirect to the original page. So it has some smarts in there, but why is it rendering that default login page versus a nice, pretty one? Well, the reason is, and why does it render the nice one when I'm doing it with JavaScript? Well, the reason is because I'm using a single page application in this instance. So if I have, in my single page application, I actually already have the HTML there. It's just making it appear. So there's my login page. And whenever it fails, I'm handling a failure just by going to the login page. But that doesn't work when I actually make a request through the browser, right? So it's going to do a redirect. So how can I fix that? And we can do that just by overriding a little bit of configuration. So we can override a method here. And a lot of people will say, well, how do I get started on some of this stuff? I can't remember the syntax for things. If you open up the superclass, you can actually see what we were doing by default. So that kind of relates to the question, where is the configuration that we had? So you can just copy paste that. And this is what we were doing by default. And what this is saying is I'll support form-based login and HTTP basic login. And so we didn't provide a login page, so Spring Security is rendering that for us. So now we're going to say, my login page is the root page. It's just the context root. And then, and it's all relative to the context root. So if you change your context root, it always includes whatever your context root is in the URLs. And then the next thing I'm going to say is I need to permit all, because if I redirect to that and I'm not authenticated, then I need to be able to view it. And the next thing is that I also have some resources on that page. And I need to be able to access those, so that's the JavaScript and CSS and all that good stuff. All right, so now if I go back to my browser, you'll see even if I request this endpoint, I'm getting the login page. And if I click login, I'm able to see it. Log out, it goes back to the page. So now I have a custom login page, and I'm able to do log out. And the other thing that we might want to check out here is that I'll make that a little bigger. And so the other thing we might want to check out is we talked about content negotiation with logout, but we also have it with login. So anyone use HTTP versus curl? It's similar, but provides some nice things like highlighting and whatnot. So what I can do is I can request an endpoint, and I'll just tell it it's JSON. Well, first we'll do it without JSON. And I'm not sure how visible this, how nice this is going to display, because it's probably going to wrap a lot with this resolution that I have. But you can see that I'm getting a 302 there, so it's doing a redirect. But now if I do a JSON request, then I'm getting a 401. And you also notice that I'm getting www authenticate in the response. And the browser will actually get the browser will actually be able to handle these. And the reason for that is it can't handle the www authenticate, because what does that signal? Pop up that nasty dialog that you can't deal with JavaScript because it can't intercept it. So instead, what you can do is I think I have to place it over here. I always forget the order and things break. X requested with. Yeah, so I just added a header, the X requested with header. Now you'll see I get a 401 and there's no www authenticate. So that's why the browser is able to handle HTTP basic response. And these are the defaults. If you don't like adding that header, you could match on something else, but there's really not a lot to go by in the request other than that. So again, it is customizable if you need to do that or desire so. All right, so now we're able to get our custom login working. And we're able to do a little bit of content negotiation. So you could see how you could easily authenticate through the browser, and you could also authenticate using a REST client. But One of the things that we kind of skimmed over is what else is Spring Security doing behind the scenes? And I'm going to just check my time here to see how much time we have, because I don't know if we're going to have to be able to do everything here to see where we're jumping to in the presentation. But we're going to go ahead and cover cross-site request forgery. And we did cover this in my last talk, but I think it's a very interesting attack, and we'll kind of build on that a little bit later. So let's assume that you're logged into a website, and you forgot to log out or just have it in your other tab, you close the tab, whatever, it doesn't really matter. And maybe it's called mybank.com, right? And then you go to evil.com. Nothing suspicious about that domain, I know. And you see a button that says win money. And who here likes to win money? Anyone? Hey, more hands than last time. I don't understand why no one raised their hand last time. They're all rich. But, you know, so everyone's going to click on this win money button, right? I know I am. So before we do that, though, I'd like to take a look at the page source so we can kind of get an idea for what's going to happen. And the page source, it's going to take a form, submit, and it's going to do a post to messages/100 of another domain. Right now it's localhost because I'm running locally, but you could imagine that it might be mybank.com. The same basically the same rules apply for a file on the file system for evil.com and mybank.com. So what's going to happen if I click on this? Well, presumably it's going to delete the message. So in order for this attack to work, we actually need to disable a couple things in here. So the first thing we're going to do is we're going to disable cross-site request forgery protection, and then we're also going to disable headers because we're probably going to do something else right after this. So at this point, I'm logged in, and I really want to click that win money button. So I'm going to go ahead and do so. And in here, you can see, actually, we probably don't even need to look at that at this point. So I click on it, it looked like nothing happened. But if you come over here, you see that there's hello Rob, but if I bring it up, hello Rob disappeared. And why did that happen? Well, the reason why it happened is because in that request, which appears to, it looks like it disappeared, but in that request, what happened was the browser is automatically going to submit the cookie with the request. So evil.com can't see the cookie, but when it submits a request to mybank.com, it's going to automatically include that in the request. So that's problematic. And some people say, well, what about if I'm using basic? Well, basic auth also gets automatically included in the request. We saw that earlier when I didn't have to retype my username and password at the very beginning. So if you're using basic auth, you also still need cross-site request forgery tokens. So how can we protect against that? Well, the easiest thing is don't disable it, is part of the step. So in Spring Security 4+, it's enabled by default. And prior to 4+, it's only in the Java config by default because XML we had to be passive, but we introduced Java config and cross-site request forgery protection at the same time. So now if I view it, you'll see that I have, let's see, oh, did I not save it? Oh, hello Rob is there. Okay, so now if I click on win money, you'll see I get this error message. And it's basically saying, where is that token? And we saw how to include it on the client side. We won't review that here, but basically the problem for evil.com now is the token isn't automatically included in the request, and it has no access to it, so it can't provide it. And Spring Security says anything that's a post, put, or a delete, I'm going to require that token. Otherwise, I'm going to block it. And the reason why we don't do it in a get is because, well, a get, you don't want to include sensitive information in because it can leak, is one thing. Another thing is you don't want your users to have to type in a GUID into the URL to say this is my domain, example.com, and cross-site request forgery token equals some random GUID. You don't want to break back button and all that stuff. So There's lots of reasons not to do it, and what's more is hopefully your application, in order to be secure, it needs to take steps like ensure that you only change on HTTP methods that you should be changing, post, put, or delete. I'm just checking the time here real quick. So that's the gist of cross-site request forgery. And there's a very similar attack called clickjacking. So who here has heard of clickjacking or UI redressing? A decent number, but plenty of hands not up. So clickjacking looks very similar. So you're logged in, you set up the scenario, you're logged in, and you forget to log out, or it's in another tab, and you go to evil.com. And once again, this room apparently likes to win money, so we know we're going to click on this button, right? So before we click on the button, though, let's check out the source. So we're going to view the source. Man, I'm telling you, it's even crazier on my screen. I have like the left half of the screen that I can see. That's why I can't see what time it is. So anyways, here's what the form, I can make that a little bigger for you guys. So the form in this instance is going to submit to a hashtag or a pound sign, whatever you want to call it, an anchor tag. So it's not actually really doing anything. But there is this iframe on there. So let's take a look at this again. And of course, this now looks wonderful. So we'll just, maybe if I refresh it, it'll... Well, it's just going to look wonderful. I don't know why it's loving my rendering so much, but because I didn't even add any styles to this. So we have the win money button, and let's change our code just ever so slightly to see what's actually happening behind the scenes. So here I have my code, and I've made the iframe invisible. But now it's semi-transparent, so now you might be seeing what's going on. I have the iframe stuck right on top of the win money button, and there's these delete links hovering right over it. And in fact, if you look at if you could see my mouse right now, as it hovers over the delete, you can see that it's clickable, but if I move to the side where the button is, but there's no link, it's not clickable. And that shows that I've overlaid it on top. So let's go ahead and undo that just to prove that it works even if it's invisible. And I click on the win money button. And it looks like nothing's happening, but I'm clicking a few times. And now if I refresh this page, there's a lot less messages. So why is that happening? We just added cross-site request forgery protection. Well, the reason why it's happening is because the token's included in the request. The iframe has the whole context. I can't read the iframe's context, but whenever I click on the delete button, it's automatically using that JavaScript we just reviewed to inject the cross-site request forgery token. So we need yet another form of defense. And fortunately for us, it's fairly easy to protect against. Don't disable things. So we're going to enable the headers again. And now we have our app back in the state it was. And now if I go to evil.com, I'm going to try to click on it. You'll see my mouse isn't even changing to the hand right now. And if we come back here and we go to our source code, you can make that semi-visible. And you'll see now there's no links. And the clue as to why that's happening is in our dev consoles. Xframe options is set to deny. So Spring Security is setting this header that's basically blocking the iframe from rendering any content, so there's nothing to actually click on. Yes, sir. So the question is, if you have multiple JVMs in the same domain, is cross-site request forgery going to work? And the answer is always, it depends. So by default, cross-site request forgery protection with Spring Security is stored in the session. So if your session works across your cluster, then it'll work in across boundaries. Now, if you're using something like sticky sessions so that it sticks on there, the same thing applies to cross-site request forgery tokens. Now, if you need ways around that, I can recommend a nice project called Spring Session, which will allow you to do clustering transparently just by adding a filter. So there's lots of options, and you can change the strategy as well. So it's a pluggable strategy. I recommend doing it in the session because basically it limits users from manipulating it and kind of protects you against potential exploits that might happen. So good question, thank you. Just checking how we're doing for time. And, okay, so we've seen a couple exploits that Spring Security can protect us against, but a lot of you seem like you're pretty familiar with it. Well, actually, there weren't that many hands. There were a number of you that were familiar with it. So let's take a look and see what other types of exploits we might be able to protect against. Now, I promised earlier that we're going to have some audience participation. And for those that came in, you might have noticed that I was desperately trying to do something. And I was trying to get something to work. And it turns out that my example was working too well. So we're gonna cover the example on the screen, and I'll tell you why it was working too well shortly. But there's probably not going to be audience participation. You'll just get to watch along. So, and this is good. I can't even see if it's still set up. So this could be a big flop. So we're going to go to Walmart.com, and yeah, I can't see my Wi-Fi connection. Oh, there it goes. So what just happened? Well, I got rickrolled, right? Obviously, I did that intentionally. And but how did that happen, and how could it happen? Well, it could happen a lot of ways. Right here, I have what's known as a Wi-Fi pineapple. And the Wi-Fi pineapple allows me to perform man-in-the-middle attacks. So how does that work? Well, one way that it can work is it can provide an SSID that looks familiar. Maybe here it might be Spring12GX, and you see it and you connect to it. Another way is enticing people. I could make a SSID of Google Fiber. People might prefer that over any other things if they see that. And you might say, well, I'm not going to connect to just any network. Who here is connected to Spring12GX? Well, that's a public one, so you probably would connect to it. It's possible it could happen. But what's more is it might happen without you even knowing it. So when you go to your house and you bring out your mobile device or your laptop, do you actually say, connect to my Wi-Fi? It just connects because it remembers. And how does that work? It works because you're sending out probe requests. So every network that you've connected to, it's remembering and it's sending out a probe request and say, hey, can you find Spring12GX? Can you find AT&T hotspot? Whatever. And this Wi-Fi pineapple actually can sniff for those probe requests. And it looks for them and it says, yes, I am AT&T hotspot. Yes, I am Starbucks. Yes, I am anything that you want me to be, and more. And so, going back to what was happening, well, apparently you guys were, I was going to try to have you guys connect to Walmart.com, but there were so many connections, it crashed the pineapple, because it was well over the number of people in this room, so I think there were people outside of the room also hitting it. And I did not have enough bandwidth because I can also forward some requests on. I did not have enough bandwidth to also make real requests to the outside world. So I had to desperately reset things and hope that things worked. So fortunately it did. But the point is that man-in-the-middle attacks are not difficult to do. This is a $100 device, so it's really easy. I mean, it's not hard to get. Obviously, don't do this for bad. I need like a disclaimer. I probably should have that in my few slides that I had. But don't do evil, do good. This is for research purposes only. Now, the other thing is people are like, well, so what is the point of this demo? And the point is to explain to you that we need HTTPS and to prove to you that man-in-the-middle is a real type of attack. Another one that's really clever that I've seen recently out there is people will use cross-site request forgery attacks, so that's why we reviewed that, cross-site request forgery attacks on your router. Okay, so how does that work? You go to evil.com. Evil.com says, I'm going to submit the default username and password for a bunch of routers to that endpoint, and then I'm going to manipulate the router and change the DNS entries to point to an evil DNS server. And now, all the traffic going through that router is potentially man-in-the-middle. So even on your home devices, if you go out to a Starbucks and you connect and you think you're downloading something and it's not over HTTPS, if it's just over HTTP, it could be me, it could be anyone, and they could send a malicious payload and set the cache headers really high. So even when you go back home, you're still going to be impacted. So HTTPS is important everywhere, and if you want to have the soapbox speech that I give, look at the previous talk. If you weren't there, you can view the recording. But there's lots of arguments as to why people think they shouldn't use it, and hopefully that'll be covered pretty well in my previous talk. But the takeaway is use HTTPS. Now, obviously, Rickrolling is not going to make me a lot of money, unless it's like a link to YouTube with ads. Maybe then I could get it. So what would I normally do? Well, here we have Walmart's site, and what would I do? I'd change this link to be a link that sends me to a secure login, and it looks like I'm having trouble connecting to the outside world. Oh, there it goes. It's just slow. So this is an app that's deployed out to the real world, and the Walmart one is actually hosted on the Wi-Fi Pineapple. This actually has a Linux distribution on it. So I can do quite a bit of things with it as I'm doing the man-in-the-middle attacks. And what happened is when I click on that login link, it's sending me to secure-walmartcfapps.io. Maybe that's pretty obvious, but if I wanted to fork over a little bit of money, I could buy a domain like securelogin.com, so walmart.securelogin.com. There's lots of ways you can get around that. Some people, if you have this safe, verified secure link or a lock or guaranteed safe, a lot of people enter their password on a HTTP site too. So, and then when I click on this link, you can see that things are not good for us. Well, maybe they are, because everyone loves the Hoff, right? So the point is that it's very easy to do exploits, and you can do a lot of things with it running over HTTP. And we really need to make sure that we're using HTTPS everywhere, including your static resources. All right, I'm going to try to get off the soapbox because we probably need to keep moving on. But so hopefully that was a semi-entertaining and informative part of the session. Let's see where we're at here. Now we're going to go on to another type of exploit. So we're going to go ahead, and this will be interesting to see the resolution on here. So I'm going to run a little bit of a demo in Internet Explorer, at least do my best. But we're going to set the stage for the situation first. So the stage for the situation is I'm allowing users to upload profile pictures, because you have to have a profile picture for your account, right? Everyone loves that. And the thing is this profile picture is going to be public. because that's just the way the site behaves. So everyone wants to be able to see it. And we're going to be able to ignore that file very easily. So we're going to do this. So fortunately, Spring Security you can disable Spring Security for certain URLs. So we're going to go ahead and disable it. Now we're going to go back to Internet Explorer and see if I can do something with this resolution. By the way, the other reason why we're disabling Spring Security for that endpoint is that my JavaScript works terribly in Internet Explorer. Imagine that. Oh, I misspelled it. Thank you. Thank you. Laughter tells me I did something wrong, and I was caught. It's good to be caught in this situation. Awesome. Thank you, guys. You guys get an award for best audience. So here, this cat has uploaded his photo, and the cat is showing off his mad skills, right? That dog didn't even see it coming. And anyone do any sort of martial arts at all? The dog's problem, he's got to keep his hands up, or I guess he's got paws, but keep your paws up, right? So that's the problem. So anyways, this cat likes to show off his picture, and he's getting this dog right in the jaw. And right now, it's just a very simple page, making sure you can see that. It's basically displaying an image, right? And the thing that's interesting about that image is that you can create an image that's valid JavaScript and a valid image. And people might be saying, huh, what? So I'm not very good at navigating the dev tools in Internet Explorer, and apparently today I'm not that great at it in Chrome. So we're going to we'll view this real quick in Chrome, so Chrome, we have the same thing here, and I keep doing. So in here, we'll go ahead and refresh the page. And now, I don't know what we'll try it one more time. Somehow it disappeared from the dev tools. I don't think it's a data. Oh, maybe I need to do this. You know what? It's probably the wrong one. It's probably the one for like a different tab. Yeah, that's what it is. If not, we'll try to explain it, and it's not that critical to. There we go. So now we can see the GIF. We can see there's. Apparently, you can't view it or maybe in the past I've done it here. So we're going to skip over viewing it, but basically the format of a GIF is you have a header, and then after the header, it has the size of the image, right? So the size of the image could be specified as a certain set of bytes, and that those bytes might actually represent a JavaScript comment. So I can comment all the bytes within the image, close the comments, or first terminate the image and then close the comments for the image, or the JavaScript, and then tack on whatever I want to the very end. So how can we use this exploit? Well, we can go into here and do oops, can't do that. Type equals text JavaScript. If you see any typos, appreciate. Yeah, that's not right. I see some typos. Anyone sees any more? All right, looks like we might be good. So now we're going to go back to our Internet Explorer, and we're going to go ahead and refresh it. Pwned. Document.write pwned is what the JavaScript is doing. So that's pretty interesting. And your mileage may vary on this sort of attack, right? So here, nothing happens. And if we viewed the dev tools, it'd say the reason why that's not working is because the content type that we've specified doesn't match JavaScript. So we're requesting a GIF, and the response says the content type is image GIF. And Chrome says, well, the content type is image GIF. I'm not going to execute this as JavaScript. So it does some smart stuff. Now, Internet Explorer, on the other hand, has a rocky history with this. And the reason why this is happening is because it's doing what's known as content sniffing. Has anyone heard of content sniffing? So content sniffing is basically saying, I'm going to guess what you actually meant by that content type rather than looking at the response headers. And that's how we get pwned. So how can we protect ourselves against this situation? And what went wrong with our configuration? Well, first of all, there's more to security than just authentication and authorization, as we're starting to hopefully see. So if we ignore security altogether, we're going to be open to certain types of attacks. So instead, what we might do is we might say, permit all on here. So we'll go ahead now and try our situation, and the header's, and it's gone. And why is that happening? Well, Spring Security is injecting a header that tells Internet Explorer, yeah, content sniffing, it's a bad idea. Wake up, it's 2015, right? Don't do it. And that, these are, like, oh, I could easily add a header, but do you know about all these exploits? Do you want to have to keep track of them all? This is my plea to you to use some sort of framework for your security purposes, because you don't want to have to keep track of those. Obviously, I'm biased towards Spring Security, but if not Spring Security, please use some other framework that provides these types of functionality for your own sake. So the interesting thing is, though, that you can still shoot yourself in the foot. Chrome can get pwned too. So you might say, well, what is going on here? I haven't seen the source. And maybe you still can't see it with that resolution. So is that all right? Can you guys see that? So here you see I have the script is image-js, but the image is also image-js.js. So it's the exact same file we saw earlier, but the file extension has changed. So what's different? Now what's happening is I'm setting the wrong content type on that image. I told Chrome that this is text JavaScript implicitly by just changing the file extension. So what is our takeaway from these scenarios? Well, first takeaway is you probably want to use Chrome in your day-to-day life. Another takeaway is that don't disable security, permit all. There's a big difference between the two. Another takeaway is that the content type is important, right? If we set the wrong content type, these sorts of exploits are still open even to the more secure browsers. And is this Chrome's fault that it's doing this? No, we told it explicitly the wrong thing to do. And honestly, it looks like it could be the right thing to do. It is valid JavaScript. So it's not Chrome's fault that this is happening. And another takeaway from this is be very careful if you let people upload any sort of files. There's other types of polyglots that are available. So be very careful if you let people upload files to your system. There's a lot of measures that you need to take in order to secure them. But in our instance, a few things you might do is put it on a separate domain, resize the image slightly because that could remove some JavaScript from it. Another thing is make sure you set your content type properly. Don't let them set the name of the image. If you let them set the name of the image, it might end in .js, and then you might render it with the wrong content type. It might have a cross-site scripting vulnerability in the name of the image. So there's lots and lots of steps that you need to take to allow people to upload files to your system. All right, so, yeah. So the question is, what does using a different domain do for me in terms of security for the images? Well, any user-provided content, if you put it on a separate domain, then it basically is it's isolated to that domain. So you're basically getting the built-in support from the browser that protects working across domains. Does that make sense? Helps sandbox it. Good question. Good question. Any other questions? Yes, sir. Okay, so the question is, the malicious user has to include the script tag. So at that point, aren't they hosed anyways? And the answer is not necessarily. Most attacks aren't a easy one exploit. They find 1, 2, 3, maybe 10 vulnerabilities within a site, and they combine them to form something. So if they needed to get valid JavaScript on the site, this is how they could do it. Now, in terms of how would they add it to the script tag, well, they might be able to add it to like a on-click tag somehow. So there's different things, and we'll actually see a little bit more with cross-site scripting in a moment. And it's not your average. Well, maybe it is average. It'll have some subtleties that might enlighten how you might go about doing that. Does that help, at least for now? All right. Keep checking the time because I haven't processed it because I'm not good at multitasking. And hopefully we can get to all our content and still have time for questions. So we've seen how we can have a polyglot file and how that can cause us some problems. But let's take a look at another scenario. So I'm going to manipulate this just a little bit to set up our situation. I'm going to include our cross-site scripting demo in permit all. And I'm also going to temporarily disable our headers. So we all, hopefully at this point, we agree that that's not necessarily the best idea, but I want to show you what can happen if you don't have the headers, and then we can see what happens if you leave them on. And the permit all there is there so we don't have to deal with logging in, and because, well, let's face it, my JavaScript is terrible, and we can't log in with Internet Explorer. So I'm going to go to a page. This page doesn't look suspect at all, does it? I'm very bad at this hacking thing. So there's different types of cross-site scripting attacks. So who here has heard of reflected cross-site scripting and knows what it is? Not very many hands. Okay, everyone's asleep. It's been boring. So a reflected type of attack is where you basically enter some information and submit it to the browser, and then it's echoed back to the screen. A typical scenario that's easy to imagine is, say I'm on Google and I type in hello Rob, and then the results say, your search results, hello Rob, return 5 million results or whatever. But you could also type in script alert 1 end script, and if it echoes that back out and you don't encode it properly, you get cross-site scripting. Now the browser can actually do a pretty good job of detecting this in many instances, right? So that's kind of nice because if it sees it in the request and then it's in the response and interpreted as JavaScript, then it can do certain things to protect you. And a lot of browsers have this built in. So when I click on this reflected attack, in Internet Explorer, I get this alert 1. So that's our problem. And so how do we fix it? Let's take a look at our the problem is that I'm not HTML encoding my message. It's pretty self-explanatory. So it's just echoing back a HTTP parameter. And in all fairness to Internet Explorer, I actually had to, for this version at least, explicitly disable their built-in cross-site scripting, reflected cross-site scripting protection. Now you might say, well, why would you do that? Well, I probably wouldn't do that because I wouldn't be in Internet Explorer, but people that use Internet Explorer are very used to that nice slider bar that they have. I want high security, medium security, low security, no security. You know, it's a nice slider bar. And a lot of times, corporations or whoever is saying, if you know, some website, if you want to use this feature, just slide this bar, and it changes gobs of settings, including potentially this one. So there are situations where this might have happened. Now you might say, well, what are you going to do if you change the settings? You know, the user's kind of at their own risk at that point. And that's true, but we also still want to keep our users safe as possible. So if I remove the disable headers, and we go back to our page, and I click on the reflected attack, and I refresh the page. Oh, maybe it's not restarted. Imagine it would have by now. Oh, right. Whew. Yeah, so I'm not on a Mac right now because I'm on a VM, and those key bindings don't work. Who'd have thought? And the refresh key binding that I clicked did not also work. So, and that's still not working. Fun. Demos. Let's see. Let's try this. Sometimes this happens to me. So sometimes the dev tools actually don't pick up what I wanted it to pick up. So let's just try that real quick. So the idea is that I can include a header in the response. And if this demo doesn't work, we might just move on because there's plenty more that we can do. And you can try it on your own because the source code will be available. But the idea is that you can add a header to the response, and it'll explicitly enable the reflected cross-site scripting protection. And it's still happening. So, you know, I don't even know how to clear the cache. It probably is, actually, but in Internet Explorer, I'm not really sure how to do it. I'm forcing a refresh as far as I'm aware. We're just, what's that? Yeah, I think rather than troubleshoot this, we're just gonna say we're gonna keep moving on because, in principle, it's pretty easy to understand what's happening. The demo gods are not with me, so we're just gonna call that and keep moving because there is some other content that I'd like to get to. We're far from finishing because you guys have had great questions. So thank you for those questions too. So, anyways. The idea is you add this header, and then it's going to explicitly enable it. What's more is it also sets the mode. So there's different modes of reflective cross-site scripting protection. And one of those modes is blocking, and another one is, hey, can you modify the request just a little bit and try to render the rest of the page? Well, certain browsers that shall remain nameless, Internet Explorer. Do you hear it? Hear someone coughing? Internet Explorer has had a bad history of modifying the request, and the request was actually secure. They did everything right. There was no cross-site scripting. Modified the request, and now they had a cross-site scripting vulnerability. So if you explicitly set the mode to block, that won't happen. So the thing is, great, now I don't have to worry about cross-site scripting. Browsers do that for me. Is that what we're learning here? No, not at all. There's other types of cross-site scripting attacks. So persistent is another type. So instead of echoing back a request, it might be something that's stored in the database. So let's go ahead and look at this JSP. So I'm using a JSP here because my hope was that more people would understand that than any other templating language that I use. But can anyone find the cross-site scripting vulnerability on this page? Just shout it out. Anyone? What's that? Line 17. 14. So 14 is a pretty hot line, and the answer is yes. There is a. Right now, we're not doing cout on that, right? So this onClick, this is actually my valid JavaScript for the process. But honestly, he may be onto something because we're going to visit that line again. So maybe he's ahead of the presentation. So if I do something like this, then that fixes it. So I'm not even going to run the attack because it was obvious. Everyone saw what was going on. So if I hit safe, then that's not going to do anything. And this is the expected workflow. I click process text. It says ready to hack. That's what I want to happen, is I want it to echo out the message. And then the HTML style one, this is what I would have done if it hadn't been escaped. It would have given an alert, but it was so obvious you guys caught that very easily. And then and then there's the next one. And what is the next issue? I'm doing a C out here, so it looks like things might be fine. But the problem is encoding is context sensitive. This is not only in an HTML environment. This is not only HTML, but it's also JavaScript. So there's two different ways that you have to encode this content. This is not safe. So how would I do that? Here is what the value is that's going to be injected into there. And it is HTML escape. The quote, the single quote is HTML escape. But you know what? JavaScript is going to interpret that as a quote. And we're going to close the quote, and then I'm going to do a document, thank you, come again. So when I click on the process, done processing, empty string, thank you, come again. Cross-site scripting is not that easy to solve. So what steps can I do to protect myself against stuff like this? Well, first of all, content-sensitive encoding is important. But the other thing that we can do is we can use content security policy. Check our time here. We can use content security policy. So how can I do that? Well, Spring Security has had support for header-based security for quite some time. And you could add it using the generic header support in the past. But 4.1 is going to have a DSL for it. So let's take a look. This is just a nice sneak peek at that DSL. So I can do CSP. And then I'll say default source and self. And I'll explain what this is doing in just a second. So content security policy is a way of adding headers that add additional security to you. And the default source is saying anything, well, we're paraphrasing so we can cover more content, but anything with a source tag attribute, it must be coming from my domain. It also means that you can't have inline JavaScript. So if someone inserts something that's a cross-site scripting attack, it's not going to work anymore. So let's take a look at what happens. So if I come here, looks like it's restarting. It's either restarting or not working restarting. Yeah, it looks like it started. Wow, I don't know how that happened. All right, great. So now if I click on contextual, nothing's actually happening. And if we look at the console, it'd be because it's violating the content security policy. So how do we fix? The other thing, though, is the mere fact that we actually have inline JavaScript, like this process function, is forbidden by this. So what are we supposed to do? Well, first of all, we externalize our JavaScript. It should be an external file. And here we're saying if you click on the ID of P, then you need to find an attribute by the name of databind on that, and then process that as a message. And then we can go to fix JSP, and we can see that in my JSP, I'm basically outputting that attribute to the databind. Now, one little caveat here is an HTML attribute is not the same type of encoding as HTML. It actually should be slightly different. So this is still not quite right. But if we add the quotes, we're good. If you forget the quotes, you're still vulnerable. So the quotes are actually very important. But really, we should not do that. But you know what? JSPs don't have a way to encode that properly. They don't have a way to provide JavaScript encoding properly. Now, there are external libraries, but not into the servlet container. So this is fine if we remember to add the quotes. And then we put an external JavaScript file. And now we can go to our fixed version of this. And I can process the text just as we would expect. HTML, just as we would expect. Contextual, just as we would expect. So we fixed our vulnerabilities. So you can see that a lot of times things are layered. And there's all sorts of other things. You might do double encoding. If you encode things twice, you can be open to cross-site scripting vulnerabilities. Cross-site scripting is notoriously difficult to get right, protecting against it. So it's not just HTML encoding. It's context sensitive. Hopefully that helps. And the other thing is our CSP is, so we demonstrated how we had to change it, so we fixed the vulnerabilities. But let's say we now had a situation where we accidentally had a cross-site scripting vulnerability. Well, what do you know? The CSP is going to jump in and say, nope, you can't do that. So that's why the CSP is, first of all, encouraging us to do best practices. And then it's also stepping in if something violates those best practices, like someone trying to be malicious. So the CSP is really giving us a second layer of defense in case we messed up. So the question is, content security policy is only in 4.2, and the answer is no, it's in 4.1, and it's only, actually, honestly, that DSL you see is only on my laptop. But there is header support, and you can still inject the generic header. It's just it's not going to provide you a fluent API for building it. So you can add any generic headers with Spring Security's header support, and it'll work just as well. There's actually a section in the reference documentation that talks about how to add content security policy too. So if you're wanting to look at how to do that, this is just a nice, basically I want to get it more out there. And content security policy has matured somewhat, so I'm fairly comfortable providing a DSL. It's actually, CSP2 is still, last I knew, in the works, so it's not final. But the plan is to provide a DSL for whatever that is, and yeah, there might be a non-breaking change in that, but it's only if the specification changes. So you probably want to see the non-breaking change at that point because it's probably not helping you anyways. So does that answer your question? All right, we actually have quite a bit more content, but due to some technical difficulties and awesome questions, I don't think we're going to get much further. Instead, I'd like to open the floor up to questions if you have them. So, yes, sir. So the question is, what beyond the sensible defaults would you recommend with Spring Security? Well, that is a very difficult question, and the reason for that is the problem is security is everywhere, right? So one person comes up to me and they said, you know, I have this question, does Spring Security solve all of my security issues? And I say, no, it doesn't. And they're like, well, why not? And I say, well, it's focused on application security, and you know what? Even that, it doesn't solve everything. So let's consider a situation. Let's say you have the ability to transfer funds from your checking to someone else's account, and someone's clever and enters in, I want to transfer negative $1 million to someone's account. Is Spring Security going to save you from that? Is that a security exploit? Spring Security certainly cannot do everything for you. Unfortunate as it is. So even in the application security space, it's not going to do everything. Do we set everything that we think should be set by default? Yes. And I will say that we will do that in major releases. So if we, as security evolves, we aren't going to enable things by default until the next major release. But we will highlight them on the milestone releases saying, hey, here's a new feature, make sure you enable it. And we try to make it very easy to enable it with the default settings that we think are appropriate. So the answer is probably not what you were looking for, but security is hard and you really have to be aware. But Spring Security is out there to be your best friend and try to steer you in the right direction. So I apologize, that's probably not what you're looking for, but that's the best I got for you. And if anyone has an auto security feature that they can implement for Spring Security, I'd be willing to take it. So if you can cover that scenario, pull requests are welcome for that or any other things. Yes, sir. So the question is the old XML configuration deprecated? And is there a way to migrate between the two? So one of the things, so let's talk about the migration first, just because I thought of that answer first, and I'd like to cover it. So hopefully it's semi-apparent when you look at my syntax highlighting, but I'll give you hopefully a better answer in a moment. The HTTP is a HTTP XML element. It pretty much corresponds to that. There's some subtle differences, like authorized requests used to be intercept URLs, but that was to fix a little bit of a quirk in there. But form login, it's another XML element. What are the attributes of that XML element? Login page. So hopefully that makes it a little easier to read for you, and that's why I format it that way. There's actually a whole blog post on how to format it and make it readable. And by the way, formatting with the Java config is paramount, because if you have it in one line, it's impossible to read. And if you haven't done so, Google for how to format the code, and it'll give you some tips with getting it to work with your IDE formatter and stuff too. But the next question is XML configuration deprecated? No. The answer is no. We will continue to support XML configuration, and so does the rest of the portfolio. The thing is a lot of people just prefer the Java config, so we tend to showcase that. And also for people that have been doing it for a while, it gives them something new to see as well. So does that answer your questions? Great. Any more questions? Yes, sir. So the question is, for the clickjacking attack with the iframe, what if my application needs iframes? So the default for Spring Security is to set the xframe options to deny. But you can also set it to same origin. So that means that your current origin could frame that content, and then any evil.com site, assuming it's on a different domain, would not be able to frame your content. There's also options for specifying which specific origins, but your mileage may vary based upon the browser support. I mean, honestly, a lot of these features, your mileage will vary. I mean, like IE6, it's not going to respect hardly any of those settings. Another thing to add to that, a lot of people also add frame busting script to bust out of the frames. That's actually fairly fragile, but it's not a bad idea to do in addition. But frame busting scripts to prevent clickjacking attacks are notoriously hard to get right. Yes, sir. How can you do that here? So the question is, with XML, I can say for a given URL, you must be fully authenticated, and for another URL, you must be something else, like role admin maybe. Is that acceptable? So this authorized request is corresponding to that, and we have ant matchers here. So let's say I want to do, well, actually, we already have the authenticated. So any request, you must be authenticated. And that's all you have to do for any request. But if I want to add an admin, then I add one before it. Now if it starts with admin, you have to have the role admin. And the other thing to point out is the order of these matters, right? So just like the XML configuration, when you specify the intercept URL elements, the order matters, same thing here. The difference is that we're allowing you to specify the type of matchers, because it's actually a little more powerful, because I can just pass in I can pass in regex matchers. I can actually do custom implementations of matchers, and with Lambda expressions, that's really powerful, right? So you can match on lots of things this way. Oh, you want to support Remember Me authentication? Well, I don't know that we can go through a whole application settings, but hopefully the form login, earlier I was saying it kind of looks like what the XML configuration would look like. And Remember Me, when you're doing it with XML, has a Remember Me element. And the other thing is, where are the ands coming in? Ands are the way of returning to the parent object so you can continue figuring HTTP, almost like closing an XML tag, right? And you don't have to use the ands. If you want, you could just stop there, hit a semicolon, and then start again from the top. It doesn't care how you do it. It's just hopefully making it an easy way to do a fluent API. Is it? So the comment is, it seems like it's easier in XML, and I think the answer to that is, as always, it depends. So it depends on the user and what you're used to. It depends on what you prefer. That's why we still support XML. There's no reason, if you don't want to go to Java config, don't go to Java config. We're flexible. So I think, let's see, I think we're actually out of time. And I will get to any questions that I didn't get to, but I need to also wrap up so that the next speaker can come up here. But if you have additional questions, I can, while I'm shutting down, you can come up here and talk to me, or even after I'm done shutting down. Thank you very much for your attention. I really appreciate your time.